So what do I need? I need the PowerPoint. Do I really want to do that? No, that's not what I wanted to do. Yeah. This is a list of things you're going to have to do. You have to do. It's not like, well, I don't want to do that. You lose point. Each one will be worth 4 points. So with bracket, I usually scheme of with graphing is gone. So this is how we're going to do it. So each one of these is worth 4 points. So the polynomial function that you're going to be given the graph. How many? 44 points for this one problem. The first exam in my pre-calculus class, the first problem on their exam was worth 64 points. So, because there was a lot of stuff to do. So that's kind of the deal here.
I have a question.
Yes.
So I'm doing the review ahead of time.
Oh, yeah.
So for one of them, there are 2 factors. I haven't looked
Yeah, you have to list them all.
all of them.
So yeah, when it says find the linear factors, that means you're going to factor the polynomial.
Oh, I'm sorry, the rational zero.
The rational zeros, you list them all.
Okay.
The potential rational zeros. So which one was that? Was it from this?
Yes.
Okay. And so that was this problem?
Yes.
Yeah, we'll start with that. So I'll work 1 or 2 of these, and then I'll cover new material, which is rational functions. So we have f of x equals 2x cubed minus 11x squared plus 12x plus 9. Okay, so the first question. So the first thing we want to answer is describe end behaviors. So describe end behaviors, I look at y equals 2x to the third. I look at the first term. What happens with the end behaviors? As you go to the left, what are the y values doing? As x goes negative, what happens? Well, just do that in the calculator. 2 times -1, 2 times -3. Right. Well, you got to cube the number. So -1 cubed is -1. -3 cubed is a -27. So I get more and more negatives. So I'm getting more negative. So it's going to go down to the left. What happens as x goes positive? What happens to the function? Goes up. Because the y values get larger and larger as x gets larger and larger. So this would be an acceptable answer for letter A. Just the arrows. Or you could write the words out. Down to the left, up to the right. Or you could use the official language that the textbook uses. As x goes to positive infinity, f of x goes to positive infinity. And as f of x goes to negative infinity, as x goes to negative infinity, f of negative x goes to negative infinity. So for letter B, I'll do the work over here. For letter B, I need to know my p-values, which are the factors of 9, plus or minus 1, plus or minus 3, plus or minus 9. And my Q values, which are the factors of the leading coefficient, which is plus or minus 1, plus or minus 2. We put the plus or minus because negative times negative is positive. So -1 times -2 is a positive 2. So we need to include those. Okay. Now, the possible rational zeros are my p-values divided by my q-values in reduced form. So if you can reduce a fraction, you reduce a fraction. So that means I'm going to take each of these values, each of these factors of 9, and I'm going to divide them one by the factors of 2. So 1 divided by 1, plus or minus 1. 3 divided by 1, plus or minus 3. 9 divided by 1, plus or minus 9. Now you could do 1 divided by 1, 1 divided by 2, and then 3 divided by 1, and then 3 divided by. That's the order in which you do it doesn't matter, as long as you do it correctly. And so I'm done dividing by the 1. Now I'm going to divide by. I think it's the same that everybody is. Okay. So now I'm going to divide each of these by 2. And I get plus or minus 1/2. Plus or minus 1/3, 3/2. And then plus or minus 9/2. Just leave them as a fraction. And so that's what I write down for my answer. Plus or minus 1, plus or minus 3, plus or minus 9, plus or minus 1/3, plus or, 1/2, plus or minus 3/2, and plus or minus 9/2. Now I'm going to use the Cartwheel signs to determine the possible number of positive and negative zeros. But first, I'm going to look at what f of negative x is before I start doing that. Because I'm going to use this for this. I'm also going to use it for letter D. So when I put a -1, I put a negative x in for x, and I have an odd degree, it's going to become negative. So this could be a minus 2x. I'm going to change the sign. X squared, it's going to stay minus 11x squared. 12. 12 times a negative x is a minus 12x. And the constant does not change. Let me call it a constant. Now, I count the number of times the sign changes. For the positives, I look at f of x. It's a positive 2, negative 11, that's one sign change. Negative 11 to positive 12, that's two sign changes. Positive 12 to positive 9, I'm done. So the number of positive is 2 or 0, 2 or none. So then I subtract 2 until I get down to 0 or 1. Okay. And now to find the number of negatives, I look at f of negative x. And I do the same thing, I count the sign changes. So it's negative, stayed negative, became plus. One sign change. So the number of negative is 1. So this is the answer to letter C. I'm not going to copy it back over there. Now to check for negative 1 and 1 is zeros, I can either put 1 in for x and find out that f of 1 equals 2 minus 11 plus 12 plus 9. And that in fact does not equal 0. What does that equal? 12. No. Yeah, 12. So f of 1 equals 12. Equals 12. So that's the point 112. Which is here. Because I'm going to need to list other points. So I have another other point. 120. Because it's not a 0. So 1 is not a 0. So right away on letter B, I can say 1 is not a 0. And now I'm going to look at negative 1 to determine is negative 1 a 0 or not. So I do the same thing, but now I'm going to look at my f of negative x. So f of negative 1 will be negative 2 minus 11 minus 12 plus 9. Well, there's no way this is going to equal 0. This is negative 25 plus 9 is a negative 16. So negative 1 gives me a negative 16. Well, I have another point that I can put here because it's not 0. Or I could have said negative 1 and negative 1 are not 0. I could have said it in one sentence. Now we're going to list all the zeros. This is where the work starts. Because this so far, I don't see this as being physical work. This is, I know 1 and negative 1 won't work, so I'm going to start with the 3. And what I'm going to do is synthetic division, because we're going to use the remainder theorem that whatever the remainder is, which is the last number we get in synthetic division, is what f of that number is. So if I'm going to do 3, and now I'm going to list now Now I'm done using f of negative x. I can just forget it now. What I want to focus on is f of x, because that's what this problem is about. So the coefficients of f of x are 2, negative 11, positive 12, and a positive 9. I skip a space, and I draw the line. I pull down the 2. 3 times 2 is 6. 6 and negative 11 is a negative 5. 13 times negative 5 is a negative 15. 12 minus 15 is a negative 3. 3 times a negative 3 is negative 9. And lo and behold, I get my first zero. Zero. So right now, I have 3. So 3 is a 0. And guess what? If it's a 0, what else is it? So when I answer letter F, I'm also answering letter G. So now we have the depressed form of the equation, which is 2x squared minus 5x minus 3. And this, once you find a 0, you can write it as x minus r. So this will be x minus 3. So x minus 3 is a factor. Remember those 4 statements are true. You know, one of them's true, you know all 4 of them. So far, we've factored it to this. Shouldn't have written that under that. Because I can continue on. I can see if negative 3 gives me a 0, because I know I'm supposed to have a negative 0. And I'm pretty sure 9 won't be a 0 because this isn't a 9. 9 won't divide that. So if I did the factoring, this is how I would do it. I do the 2x and the 2x. And I multiplied n by an extra 2, so I'm going to have to divide it out. So one of these two binomials will be divided by 2 quite nicely. And to find out what goes here and here, I multiply 2 times 3, which is 6. And I want the factors of 6 that subtract to a 5. That's 1 and 6, right? Because 6 minus to get a negative 5. So that means I did 1 minus 6 to get the negative 5. So that's going to be a plus 1 and a minus 6. So 2 divides 2 and 6 quite nicely. I'm going to keep x minus 3 up here. So now I have x minus 3 times 2x minus plus 1, times x minus 3. X minus 3 and x minus 3. So that's going to be x minus 3 squared times 2x plus 1. Well, I already know what makes this 0. We already got it, which means 3 has multiplicity 2 because it shows up twice as a 0, shows up as a 0 here and here. And now we need to determine what's the 0 from this binomial. So we do x, 2x plus 1 equals 0. Subtract 1, 2x equals a -1. Divide by 2, x equals a -1/2. So there's my next 0. -1/2. So, and -1/2 has a multiplicity of 1 because it only shows up as a 0 once. 2 times a -1/2 is a -1, and -1 plus 1 is 0. I know I'm kind of flying through this, so stop me if I'm gone too fast for you, or if you need me to go over something. Interesting thing is, at this point right here, I could have done 3 again. And done 3 into 2 minus 5 minus 3. Bring down the 2, multiply by 3. And that gives me 6, which gives me 1. And that'll give me 3, which will get a remainder of 0. If it gave me something other than 0, then I would use a different number.
I'm looking at here F.
What?
I'm looking at here F.
We're working on P, F, and G all at the same time. Because if you find one, you find them all. The first time, right here. Well, I knew 1 and -1 were not zeros. So I'm going to try 3. If 3 didn't work, I would try -3. If -3 didn't work, I would try 9. I keep trying them until I get one that works. Yes, ma'am. The answers here are exactly the same as the answer.
She's saying to find the answer for E to check it, use the one you got for B.
Yes. Because you want to look to see, or if I have rational zeros, it's going to be one of those numbers. And all the zeros in this case are rational. And a heads up, that's how it'll be on. How many problems are there? 16? 14? 16? Some of them don't work out nice. Yeah, I need to go through and rework them and take them out and repost it. So, how many have you done?
Yeah, I was stuck on the first one. I was stuck on that part, the one that you had just started on, because it was making sense to me. And I realized I was crazy. It was just a lot for me to handle.
So, is this helping?
A little bit, yes.
Yeah, there's a lot to do here. It's not a lot of difficult stuff. The stuff to do isn't difficult. It's remembering what to do. Okay. So G, there's really nothing to do for G because you're finding them here. And as you're finding these, you're also finding the factor, because I can write this, and I factored it, partially factored it. And then I could factor the trinomial. That's an easy do. Or you could use by grouping, or guess and check, trial and error. Trial and error, it's going to be a 2x and an X. And for 3, the factors of 3 are 3 and 1. So it's either going to be a 3 here and a 1 here. And because the signs are going to be different, I know I'm going to be subtracting the 2 middle terms. So I check. I see, is this going to give me what I want? So 2x times 1 is 2x. 3x times x is 3x. I subtract. And depending upon which direction I subtract, I'm either going to get x or negative x, but I needed a 5x. So I'm going to change where I put the 3 and the 1. 1 here and a 3 here. So 2 times 3, 2x times 3 is a 6x. And then the 1 times x is 1x. Subtracting gives me a 5x. And I needed to get a negative 5. So that means the 6 needed to be negative. So that means the 3 needed to be negative and the 1 is positive. Trying to explain that to them. I would spend almost 2 weeks on this. In order to learn. I used to anyway. Okay. So we're all the way down to G. Oh no, this was E. And this is letter F. Or this one. Leaving it like this is fine. I'll just circle it and rewrite it that way, but we don't lose points. There are professors who will take out points for that, but I'm not one of them. If this was the 14th, I would, because it's supposed to be moving on to pre-cal from it, but not this one. What's the y-intercept? No. That's the easiest question to answer. It's the constant. The constant is 9. So there's 2 ways to write it. You just write the number 9 or you write the 0.09. Either way. So you could have written the, for letter G, you could either list the 2 values of where it crosses the x-axis, or you could list the 2 points. Either way, I'm okay with. Not that picky. Because I want to know, do you know what it is? And so now letter H, letter I want to start doing letter J now. Because once I start doing letter J, I can find out what other points I need to find. Okay. So it crosses at 9 up here. And at 1/2, negative 1/2, and at positive 3. So I want to know at -1, I know what it is at -1. I know what it is at +1. So I want to find out 2 more values. I want to find out at 2 and 4. Oh, I erased it already. Oh no, I put it over here. At 1, it went up to 12. So at 1, it went higher. Go up to about here. And so now I want to know what happens at 2. So I'm gonna do synthetic division again. 2, and then I have 2, what is it? Negative 11, 12, and 9. So I bring down the 2, multiply gives me 4. Combine gives me a negative 7, multiply gives me a negative 14. Combine gives me a negative 2. Multiply is a negative 4, so this is 5. My remainder is 5. So that is the point 2, 5. Because this is telling me, the remainder theorem tells me that f of 2 equals 5. So at 2, it's at 5. So I know on this side, it's going to go up like this. And because 3 has even multiplicity, its multiplicity of 2, it has even multiplicity, which means it's just going to touch. And so it's going to touch and bounce off. And so now I'm going to find out what happens at 4. How fast is it going to infinity this direction? Over here, I already know it's going to go down to negative 16 because we found that at the beginning, trying to find out if negative 1 is a 0, and we found out it wasn't. And so it drops like a stone over here. And so at 4, I'm going to do synthetic division again using 4. So, yeah, I'm all over the place. Okay, 4, 2, negative 11, 12, and 9. So I bring down the 2, multiply by 4. Negative, so that gives me a negative 3, right? Is that right? So that'll be a negative 12, and that'll be 0. And 4 times 0 is 0, and 9 and 0 is 9. So that's the point 49. So we're back at 4, we're back up to the y-intercept level. And so boom. It's not growing as fast going up as it is going down. But, and they were, I usually plot the points as I find them. My graph is not to scale. On here, you have all these problems here, and then you have one graph. Well, in there, there's this document, and then there's another document that's just this graph, just this coordinates, and it goes from negative 20 to positive 20, negative 20 up to negative up to positive 20. So you have plenty of points to play with. And if you want to change your scale, instead of going 1 each time, going left to right, and since we have negative 1/2, I could have each line being 1/2. So this would be 1, and this would be negative 1, negative 1/2, 1, 2, 3, 4. So it spreads it out this way a little bit. But I would keep these as 1 because I go down to negative 16 and up to positive 12. So that way it keeps it on the graph. All the points I find on the graph. And try and be as accurate as you can when you're drawing your graph. I've had a number of people be real sloppy and just put points about where they're supposed to be and then just draw a line real hurriedly. And sometimes they hit the point, sometimes they don't. Even mine was like a scientific paper. So try and be as accurate as you can. I don't like drawing these things freehand. But yeah. I put a couple of them that are X to the fourth power on here. You don't have to. So letter A, this would have been, this is the only thing I need. Pick another, oh, for those of you who came in after I discussed this over here, I finally found out where they list the final exam schedule. You go to the Palo Alto page, not in ACES, and you click academics, and you go to course schedule or catalog. Go to catalog, and this is exam schedule is one of the main ones. And so, since our class is Tuesday, Thursday, starting at 2 o'clock, the exam will be Tuesday, May 10th, starting at 2:30. And you have 2 hours to take the exam. Exam 2 is postponed a week. And that Tuesday before, the 5th, we're going to have a short day. Well, maybe not a short day, but I'm going to, at 3:15, I need to be out of this room. Because I have a meeting that I can't be late for. So pick a problem. Do one more of these and then I'll move on. $15. Oh, that's a nice one. So we have f of x equals x to the third minus, plus x squared minus 9x minus 5. All right, end behaviors. How many end behaviors? Say again?
Upright.
Up to the right. What about to the left? Because it has 2 ends. Are they both going up? Are they both going down? Are they going in opposite directions? If it's an odd degree function, that's the highest exponent, they go in opposite directions. Right? X squared, they both go up or they both go down. And that's true of all even degree functions. For odd degree functions, think of a line. Or a line goes down and a line goes up. Or a line goes up this way and down that way. If this was a line, is this slope negative or positive? Positive. The one is positive. So that means it goes like this. So it goes down to the left, up to the right. What's letter B? The Gardsboro signs? I didn't check that. I always go back and I look at did it follow what I found out? No, first we list all possible rational. So we're going to look at the 9. The factors of 9 are plus or minus 1, plus or minus 3, plus or minus 9, Whether it's a 9 or a -9, it doesn't matter because the -9 and 9 have the same factors. It's just with -9, one's negative, the other's positive, and with +9, they're both the same sign. So they're both positive or both negative. The leading coefficient is 1, and 1 has only one factor. 1. This is why 1 is not considered a prime number. Prime numbers have exactly 2 factors, which is why negative numbers aren't considered prime. There's -1 times 2 and 1 times -2, so we have 4 factors, or 2, or -2. All right, so I'm gonna, so my P over Q, I forgot, plus or minus 1. Is just the factors of 9. Plus or minus 1, plus or minus 3, plus or minus 9. So this is my letter B. Now, Descartes' rule of signs, I'm going to find out what f of negative x. I put negative x here, I get a negative x to the third. I put a negative x here, it stays plus x squared. Put a negative x here, this becomes plus 9x. And the constant never changes. I can erase this. So now I count sign changes. Positive, positive, negative, 1 sign change. Stayed negative, only 1 sign change. So that means I will have 1 positive real 0. Now I look at f of negative x. Negative, positive, positive, negative. I had 2 sign changes. Changed here and changed here. It did not change here. So that's 2 sign changes. So that means 2, I subtract 2, and I get 0. So I have 2 or 0 negative real zeros. So now we move on to letter D, which is we try and determine what, we're going to find out what f of 1 is. Without just adding the coefficients of the function, 1 plus 1 plus minus 9, which is a negative 16. So 1 is not a 0. And then we're going to find out what f of negative 1 is, which is just the coefficients of f of negative x. So I get a -1 plus 1 plus 9 minus 9, which is 0. So -1 is a 0. So I have 1 0 so far. -1 is a 0. That's the next thing, right? Letter E. So one of my numbers for letter E is -1. And on letter G, one of my x-intercepts is negative. So the next thing to do is to start finding the rest of the zeros. But I know -1 is a 0. So I want to find the depressed equation. So that means I can use -1 in my synthetic division, here I have 1, 1, -9, -9, because I know my remainder over here is supposed to be a 0. I bring down the 1, I multiply by -1, I combine 1 and -1, and then I multiply by -1 again. I combine with the -0 with the -9 gives me -9. -1 minus, -1 times -9 is a +9, and that in fact does give me 0. So now I have, since -1 is a 0, then that means x minus -1 is a factor, so that means x plus 1. Right? Minus a negative is adding positive. So now I have factored it to x plus 1 times x squared. There's no x term, but there's a -9. Now that factors quite nicely. Here I have the difference of 2 squares. If you had an Algebra 1 teacher like me, I really harped on this. When you have the difference of 2 squares, you're going to get 2 binomials, and the square root of x squared is x, so you're going to have an x and an x in the beginning. The square root of 9 is 3, so you're going to have a 3 and a 3 at the end of each binomial. One of them's plus, the other one's minus. What are my other 2 zeros? I just did letter F here. I finished letter F before I finished letter E. That's okay. So I set each of these equal to 0, because I already know this one. I need to find these 2. So now I have x plus 3 equals 0, or I have x minus 3 equals 0. In the first case, I get x equals a -3. In the second case, I get x equals 3. So those are my 2 more zeros. -3 and 3. And those are my also 2 more of my x-intercepts. -3 and 3. So I have 2 negative zeros, which follows the Descartes rule of signs, and 1 positive 0, which follows Descartes rule of signs. So that's real helpful. I have 3 zeros. What's the maximum number of zeros I can have? 3. So now I'm going to plot those points. -1, -2, -3, my 0, my x-intercepts. Positive. The y-intercept, what is the y-intercept? So it's -9 or the point 0, -9. Either way is correct. Down to 9. What's the multiplicity of each of those zeros? How many times do they show up as a 0? Once. So multiplicity 1 for all 3 numbers. To me, that the pound symbol is represents numbers, not hashtag. Or it's a pound symbol. Pound. All right, sorry. Oh, finding other points. So I use this to find other points. I know what it is at one. What is it at one? Did I find that already? Did I erase it already? -16. So it goes down even further. All the way down to here. So I want to find at 2. I want to find at 4. I want to find at -2, and I want to find at -4. So I have 1, 2, 3, 4 more numbers to find. And I use this, right? Find those. Because of end behavior, I know it's going to go down to the left. This is the furthest to the left the x-intercepts are, so it's going to go down here. And it goes up to the right, so at the furthest right x-intercept, it's going to go up. And since the multiplicity of each 0 is odd, it passes through the x-axis at each of these points. So that gives me an idea of what's happening. So I'm thinking 2 is going to be either close to down here or a little bit further up. But I'll start with the -4. So -4, and it's 1, 1, -9, -9. I bring down the 1, -4 times -1 to -4. I combine is -3. -4 times -3 is a positive 12. 12 and 9 is 3. -9 is 3. 3 times, when I multiply here, I get a -12, which gives me a -21, which is going to, on the graph I provided, is 1 point below your lowest grid mark. And so you can put a point on the outside of it and just have it go back. Now -2, so I'm going to do the same thing with -2. -2, 1, 1, -9, -9, and it's going to be positive because it goes up and then it has to come back down again. And so I'll bring down the 1, that's going to be a -2, and that'll give me a -1. Multiply here, and that'll give me a +2, which is a -7. 2 times a -7 is a +14. And so that's going to be 5. So my remainder here is 5. So that's -2, 5. So I go up 5. And I have this point here. So I know it goes up like this. And I'm going to make the assumption that this is its local maximum. It may or may not be, because we're just sketching the graph. And I know this goes through this down here and it comes down to this, and I just need to know, when does it start turning down? Does it start turning down close to this or somewhere between 1 and 2, closer to 2 or? So now I'm going to put 2 in first. I'm going to do it using 2. 1, 1, -9, -9. Bring down the 1, multiply by 2, combine with 1, multiply by 2, which is 6, combine with a -9, which is a -3, multiply by 2, which gives me a -6. Combining those two gives me a -15. So 2 gives me a -15. -15 to -15 is about here. So it is local minimum is closer to the 16 than it is to the, to the 1 than it is to and then it's gonna come up like this. And I'll be lucky if 4 is on the graph. So we're gonna put 4 in. And that's gonna be 4, 1, 1, -9, -9. A large portion of working out problems at mathematics is pure tedium. Boring as shit. Okay. We bring down the 1, multiply by 4. Combine, that's a 5. Multiply by 4, that's 20. And that gives me a negative, that gives me a positive 11. So this is 44, which is going to be a 35 here. So the point 435, I can list it as one of my points, but it's not going to be on my graph, which is fine. That just tells me how fast it's shooting upward, which is pretty damn fast. You'll have a week and a half to work these out, and email me, set up a Zoom, come to class, and ask me. We'll do them. Okay. Guess what? I want hundreds. I want everybody to get 100 on this next exam. Okay. You know, I understand people make the same kind of mistakes I do, which is just little piddly mistakes, adding wrong or writing down the wrong number, those kinds of things. I cry inside when I see people do that, saying, don't do my mistakes, come on. Anyway, but you know, I have to take off a point or two for that. You know, overall effect is this is fun. Oh, shoot daggers at me. I know my role in your life. Chief executioner and torturer. Okay. The reason I pull it off of there is because if I start the machine up again and I open up a file, it'll try and put it on that screen, but the screen's not there if I don't turn that on, if I don't see it. It's kind of funky that way. So the next thing we need to do is get into the I went too far. PowerPoint. Too far. And I think oh wait, bug. Where are these damn bugs coming from? Here we go. Oh, the bounds. I don't test over this, but I'm going to go over it real quick. The bounds for your zeros. You have a lower bound and an upper bound. for your zeros. And there's a way to find those. Sometimes the bound is one of the zeros. Sometimes it is not. This is what we want. Why isn't it going? There we go. The number m, that's a capital M as opposed to a lowercase m, is an upper bound to the zeros of a polynomial if no zero f is greater than m. The number m, lowercase m, is a lower bound if no zero of f is less than m. Accordingly, if m is a lower bound and m is an upper bound, then the zeros are bounded between lowercase m and uppercase. So all the zeros would be in between here. Please notice they include the equal sign. Because the process in which we find these zeros sometimes it finds a zero, and sometimes it finds a number that's greater than the maximum zero. And same thing with the lowest. Bounds on a zero. The explanation is more confusing than actually doing. All right. If f denote a polynomial function whose leading coefficient is positive, if m is greater than 0, is a real number, and if the third row of the process of synthetic division by x minus m contains only numbers that are positive or 0, so that third row, if all you get are positive numbers or a 0, then that's an upper bound. If m is less than 0, in other words, if it's negative, is a real number, and if the third row of the process of synthetic division leaves you alternately positive and negative, or with zeros, so it'll be positive, negative, positive, negative, positive, negative, or positive, 0, positive, on that way, like that, then m is a lower. Completely understandable, right? Yeah, I understand it now. I didn't understand it. Okay. So for the polynomial function, use to find the bound, upper and lower bound. Okay. The potential rational zeros. So there's a process here. We start with, to find the upper bound, we start with the smallest positive. So that's 1. Integer, smallest integer. And so, and then you continue checking until you reach that point where they're all positive or zeros. To find the lower bound, you do the same thing, except you start with -1 and continue down until you find the appropriate pattern in the third row, which is every other number. It bounces positive, negative, positive, negative, positive, negative, or there'll be a 0 instead of. So what they're showing here is just the third row using 1 They weren't all positive. So we move on to the number 2. And we got wound up with 3, 11, 14, 3. They were all non-negative. They were all positive or 0. And so 2 is an upper bound. So you won't have a 0 greater than 2. Which means 3 and 15 are out of range. Now we repeat the process on the negative side, starting with -1. Why'd they use a 2? They should have used. They should have used 3. So, he's a fucking asshole. God, that's one reason why I've done this. Because I didn't fully understand what they were talking about. The more I understood it, all of a sudden I realized that's a typo. So what happens when you do 3? We got 3, 5, -8. And -15, so that'll be a 3, that'll be 9. That'll give me what? 14, 3 times 14. That's 42. And then subtract 8 from 42, which is 34. And then 3 times 34 is 108. And yeah, that'll be positive. So which is different than those. So does it matter whether we do the factors? Because 3 would be an upper bound, but it's not in the way they set the find it. So we start with -1, -2. I mean, start with 1, 2, 3. And then doing -1, we get a 3 and a 2. So right away, it's not alternating. So that doesn't work. So we go on with the -3, and we get 3, -4, 4, and -7, 27. So they alternate here. So all the zeros will be between -3 and 2 in this case, but if I follow the procedure they prescribed, it'd be 3. And that's all I'm going to say about that. You will not be tested. You might have homework problems over it. If you do, and you don't want to do those, email me and I'll change your point from 0. All right, intermediate value theorem. Simply put, if A and B are real numbers where A is less than B, and if f of A has a different sign than f of B, then you have to have 1 0 between A and B. Because, all right, this is for a polynomial function, since they're continuous, I have to connect these 2 points. That means I have to go across the y-axis, the x-axis. Same thing over here. Here they show an example where f of A is negative and f of B is positive. And over here, they're showing where f of A is positive and f of B is negative. Again, it has to cross the x-axis somewhere along the line at least once. You can have multiple zeros, such as the second example. But you have to have at least 1 0. And that kind of goes with the upper and lower bounds as well. Now, realizing that if it's an even degree function, that it may not have any zeros. Even degree. So n is an even number. X to the 6, x to the 24. Never seen one of those. Okay. Show that this has a real zero between -1 and 0. So you put -1 in correct. So it's a -2 plus 11 plus 7 minus 6, which is 10. All right, f of -1 is 10. And f of 0, what is f of 0? -6. So the sign changes. So it does have a 0. Now, and so now to find two consecutive integers, a and b, a and a plus 1, such that f has a 0 between them. Okay, and so that's what we did. Between -1 and 1, there's a 0 there. So I can divide this into 2 into 10. So I have -1, -0.9, -0.8, all the way up to -0.1 and 0. And I check each of these -9, -0.9, -0.8, all the way up to -1. I find out where the sign changes again. So I know the sign is going to change again. So if it changes here, then that means there's going to be a 0 between these two. And I divide that into 10 regions. And I keep doing that until I get to a decimal level that I'm looking for. Repeat the process until the desired accuracy is. We're on time. So, and you won't be tested over this, but you will have homework over it. So this kind of stuff is crazy. So we'll start with Bye-bye.